Greetings. Today I'd like to do a quick little overview of the Plura ELC, which is this device here. What is it? It's a device that converts NTP, or Network Time Protocol, to LTC, or Linear Timecode, which means you can go from a very precise time synchronization to global time and sync it to a device, timecode generator, like, for example, this BETSO. And why would you want to do that? Well, sometimes when you're on a job, they'll ask for different kinds of timecode, right? They'll either say, hey, we want timecode to start at like 1 hour, and then everything within the, just increments from there. Especially if it's a shorter shoot or something like that. And then other times they'll ask for, hey, we want this to be synchronized to real world time, right? And I will get the elephant out of the room right away. This device, not really necessary, right? It's more of a want, right? You want your LTC to be as close to real time as possible. Very few people actually need it to be. The BETSO and other products, you can get a GPS receiver for the BETSO. It hooks up to the LEMO, 5-pin LEMO, uses one of the spares for powering the device and getting the NEMA timecode out of it. And it allows you to set this very accurately to UTC. However, those devices are currently, or have been for many months now, unavailable due to the current supply chain issues that are plaguing the world here in January of 2023, right? Or have been for some time now. And that's not an inexpensive device. It's around $300, which this makes look cheap. The biggest issue with this is it's $650 because it's a very niche product, industrial, made for the broadcast world. It is a tank. I mean, it's solid metal casing. You could probably run over this with a car and it would do more damage to the wheels than it would to itself, right? But it's a niche product, and so the cost reflects that. And if you're like, nah, don't need that kind of accuracy for that kind of money, I totally understand it. But if you are interested in it, let's take a little bit further look at it, right? So what do you have? You have a solid metal box. There are a pair of M3 mounting screws on the back, and then Ethernet in, which is also power over Ethernet. This is the only way to power the device. So you will need either a PoE switch or a PoE injector. It uses about 1.2 watts based on the monitoring from my network switch. However, it identifies as a class 0 device, which means it doesn't do any class negotiation, and therefore the switch will reserve a full 16 watts for it, even though it'll never use more than 2, right? That's not the end of the world, because unless you have every single port on your switch providing power, you probably have the power budget to be able to afford that anyway, right? Most switches are fractionally loaded. And then the output, it's got a pair of RJ45 ports, which for timecode, I have to admit, was a new one on me, right? Typically we see BNC or LEMO 5 or 3.5 millimeter in the realm of audio and most cinema cameras and so forth, right? But again, this comes from a different world where, I don't know, maybe the RJ45 is the norm. To its credit, that RJ45 is a balanced signal. So if you wanted to run it some distance, I think you probably could. But for me, I had to get a couple of custom cables made. Get my custom cables from Gotham Sound. Highly recommended. They always do very good work and at reasonable prices. So what do we have here? We have a RJ45 to LIMO 5, which is using the standard timecode out. So this can be used with things like Sound Devices 8 series. It's also the LIMO input on this BETSO. And I also had them make a BNC version just in case, because sometimes you need to, like for example, if I was using not the SBox 2, but just the regular TCX2 receiver units, those are BNC in and out for timecode sync. And with this box, the two timecode outputs are phase synced with each other, right? So you'll get the exact same thing out of both, except that you can configure them slightly differently. So you could have one in UTC, which is what I've done here, and then the other in local time, which is also what I've done here. And so they will be exactly whatever your time zone offset is from each other. And the device also supports automatically setting user bits to the date, for example. And if you do it with timecode offset, it will consider the time zone offset when setting the user bits. And so let's do a quick little demo, right? So I will plug this into LTC1, which is the output that has UTC time. And if I then plug this into the BETSO, there's the little. Now, what you should notice is that because the BETSO automatically turns on when it sees timecode, it automatically turned on and jammed. And so I hold this a little closer, get it to focus. So you can see that it is saying 0038. And then, which is correct for UTC. And then if I unplug this, plug it in on the other side, you'll see that it's asking, do I want to sync, because it noticed a new thing. And so if I hit yes, jamming, and so now it says 1839, which reflects local time here in the central US time zone. And so now disconnect this and use this to sync the rest of your time network. I mean, obviously with the BETSOs, this is, you can see it's got TX set up here in the upper left. That's because this is the unit that I use as my main time source for everything. I have a bunch of the TCX2 receivers and go into everything. And then this actually usually lives in my sound bag with the BNC out connected to the input on the Scorpio. And then I'll jam the Scorpio to this, and then all the cameras and whatever are also synced to this, right? So you've got accurate time coming from this to the rest of the network. And, the BETSOs are something like a third of a frame drift over 24 hours because, they have a good TCOX clock crystal in them. And so, you don't have to really worry about syncing again for an entire day. And so, this down. So the thing I would like to do now is go through the web interface for how you configure it, right? Again, as an overview, how does this thing work? Okay, so here we are. We're looking at the Plura web interface. Again, doing this for an overview, right? The Plura has a hard-coded host name, which is AV underscore, and then the last 6 octets of its MAC address. This is not configurable. It's also only answered to via NetBIOS on the local LAN. There is no routing here. There is no remote resolvability. There is no zeroconf, Bonjour, etc. So it's resolvable on Windows, but not on Macs, or I don't know if Linux has a NetBIOS to look up by default or not. But you can also, of course, just access it via the IP address, and that'll work as well, right? And you can see this device has been up for almost 8 days, 8 hours. And if we look now at the NTP status, you can see that it thinks it's currently about minus 25 milliseconds off from the primary NTP device, which is approximately a frame in 30 frames per second, right? And then you can see stats on the host that it's connected to as well. And, you know, it's doing the normal NTP thing where NTP starts off with a very quick poll rate, you know, 4 whatever seconds, and then it backs off by powers of 2, such that as it decides the clock is fairly stable and it doesn't need to constantly not varying from pole to pole, it will back off so that you're not spamming the network with traffic. And with what I've noticed with the Plura is its max back off is 64 seconds. You know, some NTP implementations use 1024, but, you know, 2 packets once a minute, whoopee, right? In modern networks, gigabit Ethernet, etc., doesn't matter. Configuration. So you have the ability to set up to 5 different profiles. So if you've got, you know, you want one that's got UTC in one local time and another it's 2 different local times, you can save those. System lets you name the unit. Again, that does not affect the host name that it responds to on the network. You can set the password for accessing the device. You know, I haven't changed that as of yet because, you know, it's a local internal device, not really that sensitive to somebody trying to hack it. It did come with the current firmware based on what's on their website. However, in order to change the firmware or update it, you must use a Windows application. So if you're a Mac user or whatever, you'll have to figure out a solution for that if you ever need to do an update on this. Source. So one of the reasons this thing is a niche, expensive product is that they actually sell it for use with some of their other time code, or not necessarily other timing equipment aimed at broadcast. So they have devices that let you create multiple different timers that can be all running at the same time. They can be counting up, counting down. So if you're in sports, it might be how long is left in the period, or penalty box timer, or the how, you know, time left in a timeout that a team has called, whatever, right? And so it can run both up and down. You can switch between timers and show different timers. And again, that's why you might have different profiles, because if you're set up for different sports or whatever, you might be talking to different timing controllers. And then it also has NTP mode where it can just sync to NTP, right? And that's how I, and presumably you, would most likely be using this device. With the Ethernet settings, you have, in this case, you know, it's set to DHCP. In order to change that to not be DHCP, again, you have to use their Windows software. You can't do that from the web interface. And then what you can do, though, still from the web interface, is set the primary and secondary NTP server addresses. And you'll note that it only takes IP addresses. There's no way to put in names. There's no DNS settings that it has, even though if it's set to DHCP, it doesn't do DNS. And then the other thing that's a little unfortunate is it only does primary and secondary NTP, whereas with NTP, you should really have a minimum of 3, right? Because if you have 1 and it goes insane, you will blindly follow it into insanity, right? If you have 2 time sources and one of them goes insane, how do you know which one is sane? So with 3, if one of them goes insane, you can tell these 2 match and this one doesn't, so this is the one that's insane, right? Now, in this case, because there's no routing on my audio network, right? So audio VLAN, this is a private VLAN that doesn't have access to the internet, so it's just talking to my one router for that interface anyway, so oh well. Time will be accurate to probably, you know, as we were looking at it before, this NTP status, it's saying, you know, minus 24 milliseconds at the moment. That is relative to the primary host that it's chiming with, but then that primary host is going to have whatever its offset is to the host that it's chiming with, right? So NTP usually you could say is probably accurate to around 100 milliseconds if you are dealing with time sourced from over the internet, right? Whereas, but if, again, I've seen this number floating in the, you know, 1-ish millisecond range as well over the last 8 days, you know, so at least it's, if you had other devices that were chiming NTP, they'd still be pretty close to each other with regards to the local reference clock of the router. But again, since what we're really doing is using it to set leader time code device, then everything else syncs to this. This accuracy is not super relevant, right? It's still going to be way more accurate than what you could do by trying to manually key in a time of day to the time code on the user interface of the BETSO or many other time code devices. You know, they're not really well suited for accurate entry because they assume you're going to do something like set it to 1 hour 00000. So back to configuration. I'm going to skip the output for a moment because we'll look at real time. So real time lets you configure 2 different time zone settings, which can then be referenced on the outputs. I changed my time zone 1 to US Central because that's my local time zone. It automatically knew the right start and end dates, so it's got a fairly accurate table of time zones that would appear. The default is, for both of them, was Central European because that's where Plura's headquarters are, right? And we'll go to output now. So with output, remember I said both outputs are phase locked to each other. So you have one, what is the time code frame rate that you're using? And the one thing that's a little unfortunate is there's no 2997 drop frame. So when you sync your time code generator to this, it's always going to see that drop frame flag. And so if you can see on the BETSO, it says 2997 drop frame. So if you have somebody that requires non-drop, then you're going to have to do something like use the cross-sync option on the BETSO to specify non-drop from the drop frame. But probably most post houses won't care too much, right? If everything, what they care about is everything matches up. And then you can set what the 2 different outputs are, right? So because we're in NTP mode, the first setting is the time zone, right? So again, you can pick UTC or one of the 2 time zone settings. So again, my first output is UTC, second output is the local time zone. You can specify a variety of different formats for the user bits. The set option says use whatever you've manually entered in the set user bits. You can set the gain on the end, because LTC is analog audio, right? It's digital signal encoded in an analog signal, right? So you can set the gain. So if you're using, you know, commercial gear, if you're using consumer gear, they usually have different levels that they want, right? So if you're feeding this into a mirrorless camera, you'd want to drop that down. Where with the Betso, the default 6.2 works just fine, right? Digits, this would apply, again, if your source was set to that MTD mode. It doesn't apply in NTP mode. The PC bit is enabling or not the synchronization bit, which makes sure that there's an exact number of zeros and ones in the signal, right? So not really necessary for most devices, but if you're hooking it up to a scope or whatever, it'll keep the scope clean. And then still is another feature that you basically don't need, because in NTP mode, at least, because time is always increasing, still affects the MTD mode with count up, count down. And like I say, you've got the ability to set the LTC1 output and the LTC2 output differently. So if you wanted different user bits or different time zone, different gain, because one's going into a mirrorless camera and the other goes into your generator or whatever, you can do that. And so that's been a quick look at the Plura ELC. Like I say, it is a niche device. It is something that's more of a want than a need to have your time synchronized to real world time. It is expensive. There is no denying that, because it is a niche product. When I was looking for these things, Googling around, basically it was the only thing that showed up at all that was remotely practical, because the other stuff is all aimed at, you know, scientific research at what it's rack mount devices, not really portable, and even more expensive, right? So if you have any questions, please let me know in the comments down below. Otherwise, thank you.